So what am I going to talk about? I am going to talk about Bell Labs, but not really about Bell Labs per se, about Bell Labs philosophy, because that's the interesting part. It's 90 years old, it's won Nobel Prizes and National Medals of Science and Technology, and Grammys, Emmys, Oscars, and we win those, though, by accident. It's a nice accident, admittedly, but that we win them by accident. What we try and do, the focus of Bell Labs, and has been for the 90 years, is solve the problems that confront humanity, call them human need problems. How does humanity have to exist, or how should it exist in the future? We set the timeline at roughly 10 years. The reason we do that is everyone agrees 40 years means after I'm dead, which means anyone will predict anything in the 40-year horizon because it just means after I'm dead. But 10 years seems about right to say beyond today, but I'm not dead. So that's our 10-year horizon. So we think 10 years out, actually it's probably more like 15 or 20 in reality. And then we say, well, what is it that humans should be doing then to live better existences? And then we identify the technical problems that exist, and then we solve those. And when you do it that way, it turns out you win Nobel Prizes because you end up discovering things that you otherwise wouldn't. So I'll give you just one example. I won a Nobel Prize for discovering the origin of the universe. Now, you would think for sure that means they're just playing in Bell Labs. But no, we were actually trying to do radio communications between New Jersey and Maine, which is up north in the US, bouncing it off a Mylar balloon. The balloon, there were no satellites back then. Balloon was 10-meter diameter. If you imagine that being in low Earth atmosphere and we're bouncing the signal around, you didn't get much of a signal. In fact, you got noise. We had to eliminate all noise to even read the signal. And after a lot of investigation, including the theory that the pigeon droppings in the antenna were responsible, we went that low. We discovered it was the hiss from the Big Bang radiation, the so-called microwave background. So we won a Nobel Prize by accident while we were doing radio communications. And that's sort of how it works. So the reason for that preamble is to show you, I'm going to tell you how we see the future. And if we all understand that together, the opportunity is huge to invent amazing things. The particularly interesting part of this future is it is going to be a creative, aesthetic, humanistic future that we have to build, because I think we'll all agree we're not in that world today. We're in a techie world, but tech isn't really helping. Tech is actually acting as a bit like a drug dealer, drug pusher, of actually just making us more consumed by data and applications that aren't providing perhaps preeminent human value, but they're addictive. So we've got to get down to that, and we're going to look at a future where, in fact, it's a human revolution that's going to happen. And that's what I'll tell you, not only what I see it being, but also how we have to build it. So it's about a revolution. You all know this T-shirt. It's propagated everywhere. Keep calm and do something. Well, keep calm. The revolution is coming. I'm going to talk about technological revolutions, but only in the context of how they are going to drive a human revolution. Because technology, for technology's sake, is not that interesting. It's only interesting when you understand it's an enabler of a human revolution. So let's look at what a technological revolution is. It's actually defined by economists. First of all, you have to have a new technology. That's not surprising, because it is, after all, called a technological revolution. You have to network it. In fact, it's always key that you network these technologies so the power goes up according to something called Metcalfe's law, which basically says the power of a network goes up in proportion to the square of the number of connected things. It's just a square law. So you network a new technology, and you've got the beginning of a technological revolution. However, to qualify as a revolution, economists say it has to have the power to transform society and economies. So there aren't many, it turns out, when you apply all those criteria. These are the ones that have existed. There were earlier ones, by the way. They consider the Phoenician alphabet and printing press as before these, sort of in the BC period or 1300, but these are the recent ones. There was a financial revolution. It was basically stocks and bonds, think of it that way, and the network in that case was a market that you created between people trading stocks and bonds. It was a physical network. Then there were two industrial revolutions. You all pretty much understand what those were. It was about using new techniques to refine iron ore, etc., and aluminium, and then creating rail and engines that traveled over that rail, and the same with shipping and planes and cars. So that's what the first and second industrial revolutions did. There was one then called the scientific technical that no one's really sure whether that was a revolution or not. It might be embedded in the information age, because that was really about shipping bits around. And I think in the end, the bits became bytes, and that was the information age. So everyone agrees that the information age was probably the third industrial revolution. But they also say that one's over, and we're entering the fourth industrial revolution. In Europe, it's often called Industry 4.0, but the other way is to call it an industrial revolution. And that's about this thing called IoT and big data and AI, but fundamentally it's about automating things, and that's going to be my argument. What we're going to automate, though, is the mundane things that people do, not the cognitive, creative things. And that's consistent with what other people have said in their talks. The AI pathology or fervor is actually, should be understood as machines are good at doing repetitive things. They are not good at doing creative things. In fact, that's the one thing that humans are good at, and they're not good at mundane things. So the revolution is going to be machines taking over mundane tasks, freeing us up to do more cognitive, aesthetic, creative things. So you can already see how this is a big change in human behavior. And money is going to appear to do this. This is the amazing thing. So we'll go forward with that story. So that's what I'm going to talk about, this automation of everything. And its goal, if you think about why do you automate? You automate to create time. That's the only reason. And then you spend that time on something, and we'll talk about that too. So let's start with time. I'm going to argue that it's actually what humans have done throughout history. Everything we've invented has been pretty much designed to create time. But before I go on with that, I want to actually talk about the human part. This thing is called Maslow's hierarchy of human needs. It's evolved a bit over time, but it actually says what people want. Think of it that way. At the bottom are considered relatively mundane things, and at the top are the cognitive, aesthetic, and in fact, as you see at the top, transcendence, which basically means you feel completely fulfilled, and in fact, you have time to teach others, because it says at the top there, helping others self-actualize. So you're actually sharing your sort of collective behavior. You have time to engage in collective behaviors, and that's considered the highest order of human desire. So that's what we're going after, and this talk is about how to get there. So the trick, though, and that's what the two arrows mean, is you need to save time on the mundane to free up time to do the cognitive aesthetic things. And the problem we have is this. This is what we've done. We've actually made it worse. In some ways, if we add a level to the hierarchy at the bottom, we're spending more time there, and we haven't managed to climb the hierarchy. So I'm going to argue that's the problem we've created. I'm going to actually put a little more meat around that argument. We have actually made access to data and things and applications and services ubiquitous. And we have devices that help us consume that anywhere, but it hasn't improved our lives. And this is actually important because economists fret about this fact because they point out that there has been no increase in human productivity in the third industrial revolution. Yet there was after the first and second industrial revolutions. So what went wrong? And their argument is all we did was move things around and distract people. So we offshored, we outsourced, we created, we unverticalized businesses, and then we spent all the money and effort to bring them back together into some holistic system. So we're going to talk about this. But fundamentally, the goal of humankind, I'm going to argue, is to save time. And there's money associated with saving time because, in fact, it's productivity. Okay? So let's start with checking to see if you believe me. So this is a view of the past. I would argue all these things that were part of the industrial revolutions, their goal is only to save time. What is the point of a car? It's a mode of transportation that allows you to go from A to B faster, so it saves time. In fact, with autonomous vehicles, you could argue it saves even more time because now you can multitask legally instead of texting and driving. Plane, same thing. Longer distances need to go faster. Plane saves time. Printing press, that's the third one, is printing press. You can print about, or type about a page, page and a half a minute. Printing press can do 1,000 pages a minute. It just saves time. And then the last one is the Hubble Space Telescope. And you think, well, what's that doing there? Well, what's the alternative to seeing further is going there. So in fact, if you compare how far the Hubble Space Telescope can see relative to the speed at which we can move in rockets, it's about 5,000 times gain we get. It's all about saving time. The alternative was to go there, and go there would take longer. So if we look at this thesis about saving time is a universal thesis about why we've ever done anything. So let's now look at the present. Now, I'm going to pose this to you as a question. Do these save time? They save taxes? Oh, well, that's an Irish comment there. Very nice. But we'll go through them because I'm going to argue yes and no, actually. That's why I put the question mark. Google votes for whether it saves time. Hands up if it saves time. Yeah, pretty much does. I agree. It helps you provide access to data. The counter to that argument is you don't know what to do with the data. In fact, it's distracting and overwhelming, et cetera, et cetera. So it's access to data but not knowledge. So in the end, it doesn't save time, probably. Facebook, save time, waste time. I know Facebook's in the audience. It's not a criticism. It's just an observation. Does it save time? No. No one's voting for that. But actually, I will argue it tried to save time by creating digital communities. The problem is the people who appeared there were not very interesting. And in fact, they just bragged about their kids or published pictures of cats doing strange things. So, but that's us. We broke the model by our base instinct to be trivial. So that's, which actually is a human instinct, but that's what we're going to overcome in the next era. So Facebook, but I would argue the more they add news in, and I know we've talked about fake news, but if it's real news, then you're actually, the fact that they're adding multiple dimensions to the platform actually helps you save time. So I think they're on the path. Amazon, save time, waste time. So the votes are for save time, I think, right? So anyone says waste time? Yeah, it does a little bit. I agree. I'm a fan of Amazon. In fact, it's highly optimized around saving time, including delivery times, as you know. In fact, Bezos is very clear. His mantra is the following. We know him a little bit. He says the following, that Amazon's philosophy is focused on what doesn't change. And his doesn't change is people need goods delivered. They want to buy them and at a reasonable price, and they want them delivered. And it's a similar thing to sort of this human need philosophy. One of the human needs is people want goods, and they want them delivered. And so he optimizes that, so he's got the best delivery at best price company, and it saves time generally. The waste time is then all the distractions of other things he tries to get you to buy that you don't need. And then Apple, this is an interesting one. Apple saves time. Hands up for saves time. Yeah, you see, I feel the same way. Waste time then, or are people going to be on the fence? Waste time. Most people are on the fence about this because, in fact, it's a portal into those other things, right? And so that's the problem it has. Okay, so the present is, now you understand the economist saying why nothing has changed for the better is because we haven't saved time. We've always saved time before, haven't saved time. So what is the future? Let's get to that. The future is about connecting physical and digital. If you think about the thing we haven't done in the digital universe is actually connect our physical world. We are relatively disconnected from each other. We don't have complete communing of data about each other, physiological data, sentient data, sensory data. We don't have that about our planet. We don't have that about our industrial systems or our cities or our infrastructure. So that's going to change. And when we have that, that's the key to the automation of the mundane tasks. Because most of that, whether it's healthcare or driving or transportation or delivery of goods, most of that is fairly mundane most of the time. Okay? So we're going to do that. Secondly, we have to create new knowledge. The only way we solve is creating new knowledge, not data. So big data is the enemy of knowledge. Because if you think about it, the more data you have, the less insight. By definition, you have a finite amount of processing in your brain. We all believe we've maximized that. So we have to actually create new knowledge. New knowledge is all about new outcomes. There's no point in knowledge if it doesn't affect something. And the new outcomes are the things that are productivity outcomes, but also in creating new experiences. So think about it as saving time on mundane allows you to waste time or spend valuable time on creating new experiences. So it's all about playing with time. Saving on one to create on the other side. So that's what we're going to do. I actually use this picture for a reason. When I ask you, how do you think about new ideas? You probably use a pencil and paper. You can use a whiteboard, it's just the modern day equivalent. You can scribble on your tablet if you want. But most people say that's how they think about new ideas, whether it's math equations or artistic form or a stage design or whatever, you would scribble something. So if you think about it, we have, as human species, never improved our way of creating new ideas. We still use pen and paper. So that's the goal in some ways, is actually, if you think about AR, VR, mixed reality, it's all about trying to create new mediums for us to create in beyond pen and paper. This is the big problem that we've never solved as a species. All right, so I'm now going to tell you how we have to do it. Because the remarkable thing about this era is we have no choice about the how. Because here's the thing. To solve these problems I'm talking about, sort of these very sophisticated automation problems or augmented reality, virtual reality problems, Turns out there's a parameter in human reaction time that is to do with latency. You need very fast response times to automate things and for people to see AR, VR type displays or video. And so this is a plot. All it is plots the speed of light, but it does it in how far light can go in a certain period of time. So that's what it is. Vertical axis is distance. Horizontal is time. And what you see is and believe me, and I'll show you a little bit, that we've been living in a world which is about 100 millisecond latency, because it turns out that's how fast it takes your brain to process an audio signal, and we built networks based on telephony. It turns out video signals, it's the same. So we built networks that have built in 100 milliseconds of latency because there was no point in building them faster. And if you look at that, that means I can build the application that I'm talking to, 10,000 kilometers away. Just look on the axis there. So I can be 10,000 kilometers away. Now, think that, if you believe me, that there are a whole set of applications, and I'll show you in the next slide what those are, that need 1 millisecond of latency, and they're to do with autonomous things and automation and AR, VR. How far away can I be? I can only be 100 kilometers away. So that is a profound statement. If you think about what I've said, it's only about the speed of light and the fact that there's some things that need automating or AR, VR services that need very low latency. And if you combine those two factors, you end up building networks that are only 100 kilometers away, not 10,000 kilometers away. So suddenly, global becomes local. This is the true argument for localization. It's nothing to do with national boundaries and national security, et cetera. It's actually to do with this is the only way we will be able to live in future if we want to have these very rich, automated new experiences. And I mean everything has to be within 100 kilometers. The expert, the analytics, the security service, the network function, all of it has to exist within 100 kilometers. That's a big, radical change, and it's all because the speed of light isn't fast enough. So I promised I would show you what type of applications those are. Here they are. The important thing is the people and things domain is where we've been living. You'll recognize it's sensors, it's communication services, HD video. It's all been in this bandwidth latency regime that was to do with humans interacting with humans. When we're going to interact with the physical world and with machines and with systems, it turns out we need to explore those other three dimensions. You see they're much higher bandwidth than today, much higher bandwidth and lower latency, or same bandwidth, lower latency. And they're all to do, you see, it's about haptics, it's about VR, AR. Cloud RAN is the network itself. That's an interesting one, to virtualize the network and get efficiency. That one's a difficult one. And it's all around 360 video, remote control vehicles, automata, et cetera. All you have to understand is those three other spaces we've never explored before. And when we explore those, we have to go to low latency. What does it mean? It means global becomes local. So we're going to build networks that are hyper-local, save time that way. If you think about it, I no longer are shipping goods over long distances and outsourcing and offshoring, but I'm going to spend that time doing cognitive aesthetic things, and I'm going to come back to that point in a minute. So the summary of the networky part is this. We've spent 100 years building networks that look like the left-hand side. There's a device attached to a person. It has access, whether it's wireless or your broadband connection. It attaches it to an IP network. Think of that as the internet, roughly. And then there's a compute system that is 10,000 kilometers away, which is where the web service is. That's the network of today. The network of the future and the near future is on the right-hand side there, where suddenly we jam everything into the last 100 kilometers. And we need a whole set of new technologies to do with network and systems and platforms and OSs to make that work. And look at the parameters associated with it. 100 times more bandwidth, 100 times lower latency, 100 times more devices. What are the more devices? It's the things we're going to attach to our physical world so that we can optimize the mundane and spend time doing creative. The price of the device has to drop from $1,000 in Apple land to $1. And the battery life has to go from 1 day to 10 years, which is about a 3,000-fold increase. Why? Because most of these sensors will have no power source, and their only job is to say on-off. Think of a parking space, occupied, not occupied, a door open, closed. So those simple sensors that have no access to power have to last the lifetime of the function, so it's about 10 years. All of that is a revolution that has to happen within 100 kilometers of you here, and every place around the world. And then we have to federate between those separate worlds to create pseudo-global. So it's a big, radical change, and we're going to build networks that do that, and we have to do it in 10 years. 100 times change, 10 years. This is a technology revolution. But I want to come back to look at it a different way. So if you think about it, that last view was the techie view. This is the Trekkie view of what we're doing, okay? So take the jumbo jet as the network we've built so far, and then the Starship Enterprises is what we're going to build, and it'll look like the network we built so far is just piggybacking this little tiny network on top of the big Starship Enterprise. But let's go a little bit further on this analogy with Star Trek to get that human part back. So here we go. By the way, who remembers Star Trek, either the old or the new? Put your hands up if you actually know what Star Trek is, otherwise this is a really bad end to the talk. So we've solved for the communicator. This is my check against science fiction, because one of the ways to think about human need is actually look to literature, right? And the reason you look to literature, science fiction literature, is forward-looking, but also resonant with human need. The reason it's good literature in the science fiction realm and it's lauded is because it actually feels about right. So we solved for the communicator. That was the smartphone. In fact, we did better. We give ourselves credit. We created a better communicator, and we called it a smartphone. The holodeck, do you remember that one? You enter the room, and it transforms itself into your wildest fantasy of being in the Amazonian jungle. And that's virtual reality. In fact, you don't have to put a headset on. There are rooms now that do direct projection on your retina. So we sort of solved for that one. Next, replicator. This is the thing that made any dish you wanted. But in fact, that's our 3D printer. You can print pasta and foodstuffs, etc. You can also do much more with a 3D printer. So I would argue we beat that one as well. So we're doing pretty well in the Star Trek past. But let's look at the ones we haven't done. You remember these, right? Transporters, you go woodly, 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 and you end up on another planet. That's a technical terminology I just used there. But if you think about it, that's a hard one. I think we'd all agree that's hard. And in fact, it's the wrong thing to solve for. What you actually want to do is send state, meaning if I could perfectly describe this in functions of how it feels to be here and send it over to a person at the other end of a network, and they could feel like it feels to be here, that's the right answer. Actually, disembodying people and recreating them the other side is a bit silly, but they got that bit wrong. But the idea of being able to be intimate, empathetic, and enchanted as if you were there on the planet is in fact right. So I'm arguing that our goal is to virtually teleport, not actually teleport. And then the tricorder is the healthcare. It was the thing that scanned you like this, and it said, you are, you have a Klingon disease. I think that's what it did anyway. So that's the one that all digital healthcare is around, is that you're going to be either ingesting or wearing wearables that will essentially automate your health. So that one we're on the path to as well. So think about those as two fundamentally things we're going to do. The left-hand one is a very artistic, aesthetic one, and the right-hand one is a very mundane, life-preserving one, but they both have a time equation. The left-hand one saves me time in travel to have aesthetic experiences, but those aesthetic experiences are things I want to waste time on to feel better. Tricorder extends my life. It gives me more time to do the things on the left. So these are fundamentally related to that time. Now, I want to end on the point about art. So Bell Labs also, 50 years ago, started something called EAT, which stood for Experiments in Art and Technology. The initial pioneers of it with us, so there's a bunch of Bell Labs scientists, were Robert Rauschenberg, a guy called Andy Warhol, who got quite famous, John Cage, Robert Whitman, and then the Bell Labs engineers are Kluwer and Waldhauer and other people. That's what it says there. So it was clear who was more famous. We started it, though, with the idea that art was beginning to have access to digital technology, just beginning to. So they actually were fascinated by how could they transcribe art using digital technologies, how could they capture movement using cameras and tripwires and things. So that was the idea, and they did all sorts of wacky things, and it became quite famous, and it resulted in performances in New York's Armory that were called 9 Evenings. We did it 50 years ago. Bell Labs is sometimes a little bit ahead of the time. So, but on its 50th anniversary, we thought, if we really believe what we're saying here about saving time on the mundane to create a new aesthetic, a new cognitive experience, a transcendent experience, we need to get back in touch with the artist. So we've re-energized it. And in fact, these are some of the collaborators we have now. You'll see Philip King later. The guy on the bottom left, there's a guy called Reeps One who does beatboxing. In the middle is BT Wolf. New Inc. is the building. It's a building in New York that has an art tech incubator. Jasna Rock is the fashion designer that we're actually embedding sensor technologies in. And the middle guy there, does anyone know who that guy is? Gray-haired guy? Any guesses? David Byrne, very good. That's David Byrne. So we have some, that was him in our space there. So we're doing this, though, not just out of altruism, and this is the absolutely key point. If it was altruistic, it would go away. And whenever budgets became tight, we would stop doing it. This is fundamental to our exploration of how to communicate cognitively, aesthetically, empathetically in future, and then invent the solutions to doing that perfectly. And that's what Bell Labs' goal is for for the future. And it should be all of our goal, because it actually gets us out of this techie rut we're in, where we're tech-obsessed, and into a cognitive aesthetic utopia, and technology just helps us get there, and that's the right way to build the future. So with that, I'm going to leave you, and hope you enjoyed the ride. This is how it has to be in the gospel according to Marcus and Bell Labs. Thanks very much.